How you doing? What is an identity matrix? Let's take a look. So to explain what an identity matrix is, let's have a look at what the identity property says with real numbers and multiplication. So let's say I'm going to take the real number 3 times some number to equal that same original number. We call this the identity property of multiplication. 3 times what equals 3? The answer, of course, is 1. And this one represents something called the multiplicative identity. Okay, we start with 3, we multiply 3 by a number, and the 3 keeps its identity. Whatever it is here ends up here as well. And whenever that happens, it's called an identity property. And 1 is called the multiplicative identity. So what about matrices? If I take a simple 2 by 2 matrix, let's say 3 minus 1, 0, 6, and I multiply it by another matrix, and I want it to give me the same original matrix in the beginning, like so, then what we have here is our original matrix. I'll just call it matrix A. Okay, we usually use capital letters for matrices, and we end up with the same matrix A at the end. So matrix A times this identity matrix gives matrix A. Okay, it's the same kind of property here. It's just another identity property. So what is the matrix that actually allows this to happen? Well, an identity matrix is always a square matrix. Okay, so here it's like a 2 by 2 matrix. Right? It always must have the same number of rows and as columns. And the numbers in an identity matrix are as follows: 1, 0, 0, 1. Okay, like I said, it's always square. We have something called the main diagonal, and all the numbers or the entries in the main diagonal always have to be 1s. And all the other numbers must be 0s, and that's called the identity matrix. And identity matrices are usually denoted by the symbol capital I. So this is the 2 by 2 identity matrix right here, 1, 0, 0, 1. So how do we know that actually works? You don't believe me? No problem. Let's test it, okay? Let's do this matrix multiplication here and check that this is actually true. So if we're going to multiply this matrix by this matrix, we're going to do 3 times 1 is 3, and then minus 1 times 0 is 0, which is going to leave us with 3. Next one, to get this entry, 3 times 0 is 0, minus 1 times 1 is minus 1. That's correct. What about this one here? Okay, 0 times 1 is 0, 6 times 0 is 0, adding those we get 0. And this entry here, 0 times 0 is 0, 6 times 1 is 6, 0 plus 6 is 6. Okay, it works. So we could sum this up by saying any matrix times an identity matrix will give the original matrix. The identity property of matrices. Start with this matrix A, multiply by the identity matrix, and that keeps its identity, ends up there. Same as our real numbers version. And in the other order is also said to be true. What if you have the identity matrix times any other matrix? You should actually end up with that matrix A as well. Okay, here's a little exercise for you. You try it. What if you do this matrix times this matrix in that order? Do you get this one? Give it a try. Little task for you there. Another thing, identity matrices don't have to be 2 by 2. They need to be square, and they can get as big as you like, okay? The 3 by 3 identity matrix looks like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, as before, we have our main diagonal full of the 1s, and every other entry in the matrix is a 0. So here is the 3 by 3 identity matrix. And if you're in a situation, maybe in the same question where you have a 2 by 2 identity matrix and a 3 by 3 identity matrix, to distinguish between the two, you could put the 2 by 2 identity matrix, you can call it I2. And the 3 by 3 identity matrix, you can call that I3. So if you had an n by n identity matrix, you could call that IN in general. So let's verify the 3 by 3 identity matrix. See if it actually works. Let's say we have some arbitrary matrix here. Let's call this matrix B. Here is our 3 by 3 identity matrix, I. Now we may as well call it I3. Okay, will B times this identity matrix equal B again? Okay, that's what the rule states. Well, let's give it a try, see if it works. Doing matrix multiplication, you get this one. Okay, 6 times 1 is 6, minus 1 times 0 is 0, 2 times 0 is 0, leaving us with 6. Okay, let's get this entry. 6 times 0 is 0, minus 1 times 1 is minus 1, 2 times 0 is 0. Okay, adding those three, we just get the minus 1 only. Okay, this entry. 6 times 0 is 0, minus 1 times 0 is 0, 2 times 1, 2, we got something. Alright, 6, negative 1, 2, 6, negative 1, 2. Let's get this entry. 8 times 1 is 8, 5 times 0 is 0, 0, 0, 0. Okay, we're just left with 8. Okay, all the zeros seem to keep it all in balance, don't they? Let's get this entry. Okay, so this row times this column. 8 times 0 is 0, 5 ones are 5, 0, 0, 0. Okay, we had that 5. Last one over here. 8 times 0 is 0, 5 times 0 is 0, 0 times 0 is 0, all 0. Oh, as we have here. Okay, this entry. This row and this column. 2 ones are 2, 0, 0. We've got the 2. This entry. 2, 0, 0, negative 3 times 1, negative 3, and 0. Just a negative 3. And last entry here. Bottom row, last column. 2 zeros is 0. Negative 3 times 0 is 0. 4 times 1 is 4. Is this matrix B? Check it out. Looks good to me. Yes, it is identical. Okay, so it works for the 3 by 3 case. So any matrix B multiplied by the identity matrix, if it's a 3 by 3 system, we end up with that same matrix B. Okay, the matrix B will keep its identity when multiplied into the identity matrix. What about the other way around? We don't know. We'd have to see it to believe it. Fine, you don't need to trust me, but why don't you try it at home? You give this a go. The identity matrix 3 by 3 times this matrix B here, do you end up with the matrix B again? Little something for you to try. Thanks for watching. I hope you understand the concept of identity matrices now. Please leave a comment and I'll see you next time.